the quantity discount problem. Last time we talked about a learning curve problem. That is saying, okay, for this equals bus problem, if you go beyond the first 75 in your production for the hydroluxes, equals bus, then the profit of the 70s, 76 and beyond will increase. Okay, and today we're going to talk about a similar problem. Similar in that the setting is similar, but it requires different model to solve it. Okay, so problem statement is here. If this Blue Ridge hardtop problem produces more than 75 units, okay, the discount on the material will increase the unit profit to 375 for all of them. It's not saying, okay, this 375 only applies to the 76, but instead, if you produce more than 75 units, this increased profits will apply to all the product you produce. Okay, same as the second one. If you produce more than 50, then you're going to buy like a large quantity material for those hydroluxes, and you can buy them at a cheaper price, which end up with higher profit for all the hydroluxes that you're going to produce. Okay, so in your book, the book called the previous one that we talk about the quantity discount, I figured this makes more sense, so I changed them to two different problems. So if you're going to read the textbook for the corresponding problem, the quantity discount is really the learning curve problem we talked about earlier. Okay, so this is a different setting. Okay, so with this, let's think about how do we create a model for this problem to solve it. Okay, first think about the decision variables. If we start from the original Blue Ridge hardtop problem, we have x1 and x2, right? Representing the number of equals bus and hydroluxes you're going to produce. Okay, but in this problem now, this is a summary. Okay, if you produce less than 75, then the profit stays as the original one. If you produce less than 50 units for hydroluxes, the profit is this 300. But if you produce more than 75 or more than 50, the profit will change. Very similar as what we talked about last time. The profit will change. Okay, but you have to incorporate both. For example, equals bus. For equals bus, you have to include both because you don't know how many you're going to produce, right? Okay, so what did we do last time? How many decision variables do we have? 4 decision variables, right? And last time we used the 4 decision variables, 2 decision variables for the number of equals bus, one representing the number you produce in the first 75 units, and the second representing the unit starting from the 76 units. Okay, and this time, what do you guys think? Just for equals bus, what kind of decision variable or variables should we use? Should we use 1 variable, just x1, or 2 variables? Say if you use 1 variable, then how do you write out the objective function that's going to maximize the total profit? If there is no way to do so, then think about what about 2 variables? And if you use 2 variables, then what's the relationship between them? Okay, so that's the thinking process. Start from, okay, think about 1. If you use 1, what do you do? 350 x1 or 375 x1. Which one you choose, right? Depending on what the x1's number is. But we know that we can write if then else to ask the program to choose between 2 objective functions. Or actually, if you consider this one, as I said, there will be 4 objective functions. You will ask the program to choose if you just use 1 decision variable. Okay, then what about using 2? To incorporate the both profit in the objective function. Then you just turn on one of them and turn the other off. If you multiply a y, that's a nonlinear.
Okay.
And remember, don't do that. Okay, so we know we cannot multiply.
Yeah, we'll create.
Back to my question, how many decision variables do we use? For equals bars, we use 2 of them, right? Because we figure out we can use just one. Using one, it's impossible to help us write the objective function out to include both situations. Okay, and plus in this case, as we talked about last week, those profits are unit profits. Okay, and the total profits depends on the unit profit times the unit you produce. Okay, so you have to use this 350 times the quantity. Okay, and you need to turn one of them on or off. Okay, but we cannot say if this happens, choose this objective function, otherwise choose the other objective function. We can only have one objective function. Okay, so our decision variables should be, we use, one more. For the equals bars, we do the same as what we did last week. We use 2 decision variables, okay, to make it possible for us to write the objective function out. And the way they are defined will be different. So x11 means the number of equals bars, which means the total number, okay, of equals bars to produce if it is less than 75 units. And x12 is the number of equals bars, the total number, okay, to produce if it's more than 75 units. And we know that only one of them will happen, right? It's not like last time we have x11 represent a quantity within the first 75 and x12 the quantity beyond the first 75. Okay, in that case, both can exist, right? You can have, say if you produce 76 units, then your x11 will be 75, x12 will be 1 in the previous case. But in this case, we know that only one of them will be used. Okay, so when we define the decision variable to define the relationship between these two. Okay, so with the same logic, for hydrolysis, we have another 2 variables. Okay, and with the help with 2 variables representing the same thing, we can write our objective function. It would be 350 x11 plus 375 x12 plus, sorry, you need to maximize. Okay, 300 x21 plus 325 x22. That's our objective function. Okay, and we said when we define the decision variables, we need to define their relationship. Okay, so what's the relationship between x11 and x12? x11 and x12. What's the relationship? Based on the definition.
One is greater than 0, the other is 0.
Okay, so if, say if x11 is greater than 0, which means we are producing only within this first 75, right? Then x12 need to be what?
0.
Need to be 0. And at the same time,
Vice versa.
x11 need to be what? Yeah, vice versa. What's the definition on x11? If x11 is 0, what happens? x12 can be 0 too, right? Is that right? These are the only 2 situations. x12 can be what? Can be greater than or equal to 0. That's anything it can be.
Yeah.
But what happens if x12 is greater than 0? Remember what's x12? What's that? x12 is the quantity of equals bars if you produce more than 75. So if this is greater than 0, then it can be it can be either 0 or greater than or equal to, yeah, 76. Okay, so, or the other way, if x12 is greater than 0, then x11 need to be equal to 0. Oh, here, sorry, I forgot to put this one. If that's this case, it need to be less than or equal to 75. Okay, if x12 is greater than 0, then x11 need to be 0, and at the same time, and x12 need to be greater than or equal to 75, right? Right? And if x12 is 0, then x11 need to be greater than or equal to 0 and less than or equal to 75. So either of them. Okay, then look at these two sets of the logical statement. Okay, see which one do you prefer to work with. Just take a brief look. I would prefer the second one too. My reason is that here, this is pretty straightforward. If this is greater than 0, then this equals 0. This under this situation, there is only one condition you deal with, and the same for this one. And we talk about both of them. If you look at the first part, both of them include all the situations. Okay, so x12 can only be greater than 0 or equal to 0, same as this one. So with that, we don't have any. So if you draw a line from here, really, I won't prefer one over the other. Just look at the first part. Okay, because last week we talked about, you look at the first part, these two if statements need to cover all the situations that can happen. Okay, so all the situations that can be happen already covered. So if this x12 can be either greater than 0 or equal to 0. Okay, so no other situation can happen. But if you continue to look, like this one here, after this one condition, there are two more conditions that need to deal with. So this x12 should be either 0 or greater than or equal to 76. To me, that's more complex than here. Okay, so just straightforward. If this happens, then x11 0, x12 greater than or equal to 76. If this is 0, then x11 just one condition. Okay, so that's my reason of choosing this statement to work with. Because I don't want to deal with this situation where you need to deal with another situation, like x12 need to be either 0 or greater than this one. But I think both ways should lead to the same constraints. You only start with one of them, one of the decision variable, because why? Because x11 and x12 are linked together. You only start with one of them, and it leads to all the situations. You don't have to do both sets. Okay, so the question was, do you need to do both sets? You only need to choose one. Because x12, if the first set covers all the situations that can happen to x12, then we are good. Because x11 will be determined by x12 value here. Okay, so here, let's look at this, this condition that we're going to try to solve then. If x12 is greater than 0, then x11 need to be equal to 0. And at the same time, x12 need to be greater than or equal to 76. And the other situation, if this is 0, then the other variable need to be between 0 and 75. Okay, so just take a look and see if there is anything that rings a bell. It's familiar, that looks familiar to you. Pick any part of it. And that's why we said we need to be familiar with those very basic conditions.
Second line seems like you can link with a binary variable, similar to what you are doing right here.
Okay, I just remind you guys, the thing that you can link to, you just work on it.
Yeah.
Which one? Which part?
0 less than or equal to x11 less than or equal to 75.
Follow what I'm suggesting. Look at this statement. Don't think about what constraint to use first. I don't think you can get the constraint out just in a few minutes. Okay? Don't try to do that. Even don't try to do it. But follow what I'm suggesting. Look at these two statements. See if there is any part in them that remind you some problem that we did before. I don't think you can come up with a constraint just by looking at them. Okay? But follow what I'm suggesting. You see here? If x12 is greater than 0, then x12 need to be greater than or equal to 76. What kind of problem is that? Okay, the minimum order size problem, the one we just did in the exercise. Okay, so what's the constraint for that? What's the constraint for this part? Did you guys see this part? Everyone? The one that I highlighted with red. Okay, that's the minimum order size problem. Okay, if x12 is greater than 0, then it has to be greater than or equal to 76. It's saying if you produce it, then it has to be more than 76 units. Okay, then that reminds us the constraint. Okay, 76 is the minimum order size, so you put a y here. Okay, and less than or equal to m. Okay, we'll figure out this m value, which is not given yet, times the y, 1, 2. Okay, so with that, we take care of just this the red highlighted part. Okay, and then let's see, okay. When, just looking at this, okay, when y equals to 0, what do we get? To 0, right? We get x12 equal to 0. And when y12 is 1, what we get is x12 is greater than or equal to 76, less than or equal to this big M here. Okay, and so this part is what we wanted for here. Okay, and why we want to do it is because there is another thing we need to link later. Okay, which is x11 also need to be equal to 0 in this case. So what we are saying is that y12 is equal to 1. So this is some relationship that we're trying to link. Okay, we're going to link x12 with 1, 1, but we're going to use this y or another y or something. But when this x12 is greater than or equal to 76, at this moment, this y equals to be 1. Okay, so we want to link them later. Okay, good. So we get one part done. Then let's look at the other part. Okay, so when x12 is greater than 0, which is this part. Okay, then here another part. Let me use a different color. Okay, this part. We get that when y is 0, x12 is equal to 0, which is here. Okay, now x12 is 0. At this moment, y12 is 0 here. Okay, and when this x12 is 0, we want our x11 to be between 0 and 75. And when x12, when y is, or when x12 is greater than 0, which is when y is 1, we want our x11 to be 0. So now we've already taken care of the x1, 2 thing. Now what we want to achieve is, how do we write a constraint? Okay. Let me go to the next page. So your first one is x here. Here, the first thing is x11 equal to 0, okay? x11 equal to 0. At that time, the y12 equals to be 1, right? Here. I just put here to remind us. And the other thing we want to do is that it is between 0 and 75. At that time, my y12 is 0. Okay, but 1, 2, these are the two situations that I want to achieve. And to see, let's see, how do we write a constraint out so that x11 will be 0 in one case and between 0 and 75 in the other case?
If we multiply another y by the 75, would that?
So look at here again. Remember we said when you try to force a value to be equal to something in some situations. You guys remember? We want to force this x11 to be equal to 0. One thing we can do is make that is equal to this, right? Okay, and we know that for 0, we cannot just write a 0 here. And we cannot write, say, let x1, this is what we want to achieve, okay? But we cannot write just in this way. And we can't write this way either. Say that 0 times y, because, well, no matter what the y value is, you will get 0 for sure. Okay, but we know, wow, this y value will be 0 in one case, right? So if you put it on the other side, multiply some numerical value that's not other than 0, then you will force this x11 to be 0 in some situation. So put a y here, okay? And then we look at the other situation we want to achieve, which is x11 you want to be less than or equal to 75. So this 75 becomes naturally here. So put it here. Say, okay, so when this y is, when y is 0, you do get x11 equals to be 0. And when this y equals to be 1, you do get what you want here. Okay. Great, so we got both of them. Then can we use the same one? Can we use the same y to link x12? Because what? We put it here already, right? Your x12 is 1 in this case, defined by the early relationship. So this is one relationship we defined earlier. And this value here is just opposite to the other one. So that means first, we cannot use the same y. So here we'll just say, okay, let's use xyy. Oh, sorry, xy11, because it's the y that's trying to force x11 value. Okay, but are we done? We need to link them because of this relationship here. This is the entire relationship here. Okay. If we don't link the two y's, then we don't have this. We only have if x12 is greater than 0, then x12 is greater than or equal to 76. And the other will be, x will be either 0 or between 0 and 75. But we don't have this entire thing together. If we want to have this entire statement together, we need to link the two y's that we use to force both value. Okay. Make sense? Okay. Then what do we do? Look at them, they are opposite value. Good, they are binary, right? They are binary values, so we just use 1 to subtract the other value. So when y12 is 1, then we do get 0 here. And when this is 0, we do get 1. Okay, so that's the linking constraint. Okay, So let me just go back to briefly review what we talked about. We came up with two sets of the logical statements. Okay, we look at both. We decide this one is straightforward because after the condition, there's just one thing to take care of. So we decide we're going to continue with this one. And then we look at this logical statement carefully to see if there is anything that's similar that just help us jumpstart quickly to write a constraint out. Okay, of course, if you don't recognize any pattern, you can still do it, but you have to do it in a slow way. Okay, you need to try different constraints. But if we recognize the pattern, say, okay, I do see these two. When this is greater than 0, it itself has to be greater than or equal to 76. That reminds us of the minimum order size problem. And that's the constraint to use for the minimum order size problem. Okay, so we come up with this, and we just figure out, okay, what's the y value in each case? Then we try to link, because this y will need go to link this x later. And then we started, with this we took care of part of the problem. Okay, and then we look at the other part, which is the x11 value need to be either 0 or between these two. Then we talk about if you want to force to a value to be 0, you better put constraint on both sides. And in this case, it's 0, so we use the y. When y equals 0, then x1 will be 0. And looking at the other constraint, this is a little easier to come up with. And we check the relationship between the two y's and find a way to link the two y's. So before that, we would have those resource constraints, right? And these three are the linking constraints that we come up with to link our x11 with x12. Okay, so that's a constraint. And to figure out this big M value, you will do the same. Use 200. Let's just calculate here. So it will be like 200. 1566 divided by the 9 here, and 2880 divided by 12 here. And this M here should be the minimum between these two. So this will be equal to 1566 divided by 9. And this time we don't need to subtract 75, right? Because the x represents the total number you produce. It's not the starting from the 76 units. Okay, so this M will be this value. And you have these three constraints to establish the relationship between x11 and x12. Okay, then what about the other one? For hydrolysis, what would be the constraint? Once you figure out this set, can you write the other constraint? For hydrolysis, if you go beyond 50 units. If x22 is greater than 0, x21 need to be 0. And at the same time, x22 need to be greater than or equal to 51. And if x22 is 0, then x21 will be between 0 and 50. Okay, so very quickly reproduce this one. Start from the first constraint. Of course, you can just copy the pattern we had. Okay, but just quickly reproduce it. By first write out constraint for this part. If x22 is greater than 0, x22 need to be greater than or equal to 51. So what's the constraint on this one? Greater than or equal to, less than or equal to, times the y, right? Okay. And then we look at x21. For x21, it's either 0 or between 0 and 50. So you want to force it to be 0 or less than or equal to 50. So that will be x, y, y21. So that's the constraint you help achieve these two situations. And then you link both of them, right? x1, x22 equals to be 1. So these will be the three constraints. See, if you are familiar with them now, you can basically write out all the three constraints. But it's still like for every problem, check to see when say y22 value equals to be 1, what happens? When y22 equals to be 0, what happens? To see if achieved what you wanted. Okay, sometimes we come up with a constraint we think it work, and we didn't exclusively looking at enumerating all the situations that may happen. We need to check to see if it's working in all the situations. Okay, so the same for this m22 value here should be 156 divided by 6, or depending on which one is smaller. Okay, so we want to calculate this here. And make sure you specify the xij's are integers and the y's need to be binaries. Okay. Any questions here?